Hi everybody, welcome back once again to this channel. Thank you very much for joining me once again. So today we're just going to be revising this quite very interesting question from your functions from your Gauteng Province 2024 June exam, right? So guys, if you're new to the channel, please make sure you've subscribed. Just turn on that notification bell so that you can be notified every time when we upload a new session. Again, guys, if you want to support this channel, right, you can click on the join button, and there are different options on how you can support the channel. Okay, without wasting any time, let's get into it. Okay, 5.2, we are given that f of x equals to x squared plus bx plus c, g of x equals to mx plus c. Okay, and they are drawn for us there. If given f of x times g of x less than 0, let me just write this on top. F of x times g of x is less than 0 for all values of x when x is between -6 and -3, or x is greater than 2. We have to determine the value of a in terms of m. Show all workings. Okay, for 5 marks. Okay, so this question is testing quite a number of things. It's testing your understanding of inequalities in functions, whether you do understand how we get the values of x when we are given a certain inequality like this one. When we are multiplying the two functions, they must be less than 0. All right, let us start there. So what we have to do is we have to transform this into this function so that we do understand what is -6, what is -3, what is 2 in these functions. Okay, so it's very important. So firstly, how do we ensure that when you take f of x and g of x is less than 0? Okay, it means the other graph must be positive, that is, it must be above the x-axis, and the other one must be negative. That's the only way, right? Because positive times negative will result in a negative answer, and a negative answer will always be less than what? Less than 0. Okay, so either of the graphs, so f of x can also be negative, whereas g of x must be positive, that it must be above the x-axis. That is the way in which when we multiply the two functions will be less than 0. So we're gonna check where the functions, the other one is on top and the other one is below the x-axis. Okay, so if you check g of x, right, the function of g of x from this point here to going to that point, it's actually above the x-axis. In other words, it is positive, right? Then when we cut at this point, if you check at this point, that is where let me use a different color. This one of h of f of x is actually what? Below the x-axis. Can you see? So you can check, and we're given the interval for which that exists. They said when x is between -6 and -3. Okay, it means we can deduce that x here is actually -6 and the x here is actually what? -3, because between that interval, it's where we are noticing that actually the other one is above the x-axis and the other one is actually below the x-axis, and they told us it is between -6 and -3. All right, so another point, when x is greater than 2, so if you come and check at this point here, right, remember the other graph must be above the x-axis, the other graph must be below the x-axis. You can check that the graph of g of x is actually above the x-axis, that is, it is positive, right? You can see it's on the positive y values here. Okay, so but this one of f, at the same time, it is what? It is negative, it's below the x-axis, and they told us when x is greater than 2. So at this point, we can deduce that that is what? That is 2. All right. Okay, so if you can check, now we have managed to find the x-intercept of the parabolic function and the x-intercept of the straight line function, right? We can now go in a quest to try to get a, right? To get our a in terms of m, as asked, right? So obviously in this case, we can, because you have your x-intercept, you can use this standard form, which says f of x equals to a into x minus x1 x minus x2, right? We can't use this because it's quite, you have to get b, you have to get c, so it's better to use this when you have your x-intercept, right? We can say this is our x1, this is our x2. Okay, so you can just come and substitute a into x minus x1. It's -3. We have to be very careful. Negative and negative, that will give you positive, right? So we can say x plus 3 there, and x minus 2 as our x2 there. All right, so you now have your quadratic function in this format. Okay, now the question is, how can I now go and solve for a in terms of m, right? So what we have to use our knowledge of intersection. That is where we can now bring in m as we are trying to solve for a, right? If you check this intersection here, it is the intersection where g of x is actually equals to what? F of x. Can you see at that point? And we do know the x value there, the x value, because it's at the y-intercept. Can you see? It's at the y-intercept where the x value there is actually 0, right? Where x equals to 0, we can see that the function of f of x and g of x intersect. In other words, they are equal. That is how we can now bring in the idea of m in trying to solve for a, right? So f of x, we're going to replace it by a into x plus 3 x minus 2 is equals to your g of x. Now it's what? It is mx plus c. Can you see? G of x is mx plus c. Okay, so we need to be very careful at this point, right? Because we have not yet expressed maybe m in terms of c, right? Or c in terms of m. And that will have an effect, because if you check, if you come and substitute 0 here, the m goes away because it will be 0 plus c, right? But let us go and just continue, and we just at the end will express c in terms of m, then we'd have solved for that. So we can now substitute 0 where there's x, because at that point intersection, when x is 0, they intersect, right? 0 plus 3 is 0 minus 2. Okay, m into 0 plus c. Okay, so you have a into 3 times minus 2, right, is equals to m times 0 is 0. This will be left with c. So a will be c divided by minus 6. Can you see? A is equals to c divided by minus 6. We have actually expressed a in terms of c, but the question says express a in terms of what? In terms of m. It means at this point we have to know what is c in terms of m, right? So we have another point that can enable us then, all right, to express c in terms of m. Then we come and substitute in this equation, then we would have solved the question. All right, so what we can do at this point, we know that the y-intercept of g, the x-intercept of g is actually minus 6. Can you see? So what we can do at this point, we can come y equals to mx plus c to say, but it has an x-intercept, right? An x-intercept of what? Of -6. We know that on the x-intercept, y equals to 0. So where there is y, we put 0, mx is minus 6 plus c. Okay, now you can express c in terms of m, because you have 0 equals to minus 6m plus c. All right, so finally your c will be equals to 6m. Okay, can you see now? C is equals to 6m. We can come and substitute it there and finally get our a in terms of m. It will be, when there is 6, c will put 6m divided by minus 6. Then 6 and 6 cancels. M divided by -1, -m. So that will be an expression of a in terms of m. All right, I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon.